This is lesson 2.7, finding square roots. This is the definition of a square root. If b squared equals a, then b is the square root of a. That is, b times b equals a. So for example, if 3 squared equals 9, then 3 would be the square root of 9. 3 times itself equals 9. Therefore, it is a square root. Now, all positive numbers have two square roots, a positive square root and a negative square root. So if you were to take the square root of 25, for example, you could get positive 5 and negative 5, because 5 times 5 is 25 and negative 5 times negative 5 is 25. But the positive square root is always called the principal square root. That's the one we default to. So when I ask you for the square root of 25, normally I'm only looking for the principal square root, the positive value for the square root. If you take a look at just a little vocabulary here, when we have a square root symbol and a number or a variable under that square root symbol, the square root symbol is called a radical or a radical symbol, and the number that's underneath the radical is always called the radicand. 0 has only one square root, 0. But negative numbers have no square roots because there are no numbers multiplied by themselves that would give you a negative. When you have a positive or a negative sign in front of the radical, that tells you that we want to see both the positive and the negative square roots. But without the sign, we assume you only need to calculate the positive square root. So you're always looking for that positive negative sign to know if we're looking for two square roots. If you don't see that sign, we're going to assume we only want the positive square root. So in the examples, when we say plus or minus the square root of 36, well, the square root of 36 is 6. Then we put the plus or minus in front of the answer to know that both positive and negative 6 work for the answer here. If I ask you for the square root of 49, we're going to assume we only want the positive square root, the principal square root, and that's going to be 7. The opposite of the square root of 4, the square root of 4 is 2. That would be positive 2, but because we want the opposite of it, it's negative 2. So if you take a look at the ones below, the opposite of the square root of 9 would be the opposite of 3. The square root of 25 defaults to the positive, which would be 5. Plus and minus the square root of 64 would be both the positive and negative square roots of 64, which would be positive and negative 8. And the opposite of the square root of 81 would be the opposite of 9, because 9 is the square root of 8, so it becomes negative 9. Any square of an integer, either a positive or negative whole number, remember our definition of integers, is called a perfect square. And the square root of a perfect square is always a whole number. So for example, numbers like 64, 100, 25, those are all considered perfect squares because when you take the square root of each one, you get a whole number. So the square root of 64 would be 8, the square root of 100 would be 10, and the square root of 25 would be 5. These are all perfect squares, and we can easily find their square roots because they are in fact whole numbers. But the square root of a number that's not a perfect square is called an irrational number. An irrational number. A irrational number is a number that repeats and doesn't end. So whenever you have the bar over all the decimals at the end of a number, okay, that number doesn't end, then that means it's an irrational number. For example, if we calculate the square root of 945, we actually get 30.74085, on and on and on and on. That's called an irrational number. There's no end to it. We can't pinpoint it because it goes on forever and ever and ever. That's why it's considered irrational. So here's a word problem. And the word problem is that you know the area of a square table is 945 square inches, and you need to find the length of the side to the nearest inch. Well, since the area of a square table is s squared, side times side, to find the length of a side, you have to take the square root of 945, because some number times itself is going to get us to 945. And then once we get the answer, they want us to round that to the nearest inch. So as we talked about earlier, the square root of 945 is 30.74085, on and on and on. Okay, rounded to the nearest inch, that would be 31 inches. Okay. You should try to practice this. Try to round the following square roots to the nearest integer. The square root of 32, the nearest integer there would be 6. When you take, if you take a look at 5, that only brings you to 25, which is 7 below 32. But when you try 6 as the square root, that takes you to 36. That's within 4. So that's actually the nearest square root to the whole integer. The square root of 103, the closest square root to the nearest integer would be 10, because 10 squared is 100. The opposite of the square root of 48, to the nearest integer, the square root of 48 would be 7, because 7 times 7 is 49, right? If you went higher than that, if you went to 8, it would take you to 64, and if you went lower to 6, it would take you all the way down to 36. So it has to be 7, but we're looking for the opposite of the square root, so it's negative 7. And last, the opposite of the square root of 350 would be 19. If we go up to 20, that would be 400, right? And 18 is going to be too low. But you must note that when there's an opposite sign in front of it, we always have to make the square root negative.